All right, so welcome back. Welcome back to this channel. So over the last few videos, we have been covered majorly on image modeling, what image generation actually is. We have learned about different models like GANs and different types of GANs for different problems and different upgradations to GANs, and also we have also learned about stable diffusion, different papers on stable diffusion, video generation for using stable diffusion, and also different amazing different. I think they are pretty cool things. We have learned pretty cool like things from I think over the last few over the past few videos. So now I thought maybe we should come. I thought this is the best time to go through language modeling, because I think, yeah, definitely language modeling played a huge role in deep learning. Like in the current society, language models are creating a lot of influence in the way businesses talk to their customers. The it actually created many things easier, not only for the users but also the like clients, or the people who provide different services. So this is the best time to go to language modeling. So I thought maybe we should cover some new language models. Before that, I think BERT is a very good place to start. So it is a language model which is introduced at, I think, 2019. Like back then, before GPT, it was very famous. I remember, like, I wanted to take a course or something. Like a lot of new courses have been released on BERT at that time, and it was, I think, it created good hype in deep learning because because of its performance. So we'll be covering this BERT pre-training of deep bidirectional transformers for language understanding, or and maybe for the next one or two videos we'll be covering this BERT. So for this video, I'm going to go everything in a pretty much high level manner. I'll try my best to elaborate different things, but maybe in the future videos, or maybe the next video and the next video, we will be covering the like the step by step process of each process, and we'll be going like that. So but which is this paper is actually, and this model is actually introduced by Google, by these people, these smart people there. So let's just go through the paper, what it actually means or what it actually has introduced. So nothing much going on. So they have just introduced the different models first. They have specified some previous works. So the main part is this section. I would highly recommend you to read it. I will just I'll just explain it in a whiteboard. I'll just open that. I'll just explain it. Let's not read it. I'll just create a new word. Right. So the idea is, so the idea of the BERT is, we could actually, so this is actually a pre-trained model. This is actually a pre-trained model, and you could use this pre-trained model and fine-tune it, or train it further on different or train the model further for different tasks. So I'll just explain what that is to you. So first of all, we could build a transformer model. You could build a transformer language model, just so you know. I hope you are under the prerequisite for this video is, I really hope that you are aware of like the deep learning, what deep learning actually is, and you are aware about transformers, what it is, about what that the underlying architecture and what it performs. And like, if you like, it's just a prerequisite, right? So I think I have like videos on transformer on my YouTube channels. Make sure to check them out if you want to, if you are interested. But most importantly, I will be in this video we'll be covering this BERT variation, in which we are going to learn about this language model. So make sure to like go and visit and learn about transformers before watching this video, which is like, it is very highly recommendable to learn about the deep learning, the basics of deep learning and transformers. So again, so let's get back. So we'll train a transformer, right? We could train a transformer on huge unlabeled data, right? We could actually have like huge unlabeled data, just text data on the internet. just like how the GPT model was actually trained. So we'll have like many text data, so many sentences. Maybe we can gather it through Twitter or even something like maybe YouTube, maybe some descriptions and all that text data, right? So these are like embeddings or tokens. Think of whatever they are, or embeddings, let's say. So what we could do is we could build a transformer that could generate like the next word or the previous word. So we could actually train a transformer model on this data. So what we could do is so each box represents each word. So in this sentence, we are having like 1, 2, 3, 4 words. So we have like 4 words here. What we could do is we could actually train a model that can understand the relation between these words and let the model and make the model predict the next word. So that is exactly the idea of transformer, to predict the next word. But here we are going to make one change. So rather than just predicting the next word, so what we'll be doing is in transformer, in a normal transformer, I'm going to just recap what we'll be doing. So we'll be having like bunch of self-attention layers, right? We'll be having query key value vector for each of these words, and we are going to calculate them using some gradients, and we're going to perform the multiplication with the actual embeddings. Right? And based on that, what we'll be doing is we are going to update the parameters such that we could actually predict the next word. So the main goal is predicting the next word. So given these 2 words, let's say, we should predict the next word. And given these 3 words, we should predict the next word. So that is the idea of transformer, what we want to do. So we could actually use this method and actually create a loss function, just like an MSC or something, or even like as this process, like this, we don't even need to use like MSC. We actually use something like binary cross entropy or categorical cross entropy, because this is just a classification or just a classification problem, classify between different words the model know. Hope you are aware of these concepts in NLP. If not, just check out my the videos of my YouTube channel. I think I have covered them. I have tried my best to cover them. Anyway, so we want the model, right, to um, understand the relation between these words. So that is exactly the idea of transformers, to predict the next word, right? So by predicting the next word, the model can understand the attention between these 2 words, and we would update these parameters also based on this loss function. And the one change that we'll be doing for BERT is that rather than just predicting the next word, we would randomly, I'll just draw a better box here, right? Rather than, let's say we have 3 words, rather than just using these 2 words to predict the next word, we will be creating a bidirectional model. That is, so this is actually unidirectional model, the before transformer that I have proposed or that have been proposed. So we'll be just taking the last 2 words and predict the next word. But in the case of bidirectional networks, like in BERT, we will be masking, or we will be like masking random values. So what we could do is in this sentence, let's say, we'll be giving the model both of these values. So we'll be making the model take both of these values and predict this word. So what we'll be doing is, I'll just show you an example what is actually happening. So let's say the input is how are you, right? So let's say we want the model to predict how are you. What we would do is we would remove R, right? I'll just take an eraser, I'll just rub R, and we could just create a mask. I'll just create a mask. Sorry. Let's create a mask. I'll just cover this middle word and make the model predict the sentence, how are you? So that is the idea. So we'll be training the model such that it can understand, not only understand the like self-attention, but in the decoder, in the inference time, we want the model to actually, or in the training time, while we're actually training the model, we will just randomly mask different values. So we'll just randomly mask different values. We'll just cover up different values and make the transformer predict them based on the previous and successive words. This is the like the main change that we could see in the BERT. architecture. So the idea is in BERT, we would collect a large amount of information, a large data, right? We would just collect a large data of different sentences, right? So we'll have like a large data of different sentences. So let's say consider each table as a sentence or collection of columns as a sentence. So this is a sentence, this is a sentence, and this is a sentence, and so on. So each box inside this huge bigger box or outer box represents a word. So we'll be having these number of sentences, and of course the internet is a very huge place. So again, as this paper is actually implemented by Google, they have access to a lot of information, a lot of text data, to be precise. So as they have a lot of right, access to text data, they will have like millions of or even billions of text data or text sentences. So what we'll be doing is we'll be training this model, the transformer model, on all of this data, such that we want the model to take in like the random elements and mask of random elements and predict the like it just like underlines or like maybe like filling the missing positions. Maybe you have done that like, or maybe you have yeah, we will just fill the missing positions of words. We'll make the transformer fill the missing position of words. Hence, while training, the model will understand the text, right? The model will understand how this text actually exists, right? The relation between these texts, each words, and also it can understand how to predict the missing words. Hence, after training the model on these billions of text or sentences, what we could do is we could use this model. We could use this trained model, right, to actually and that is a pre-trained model. So the current trained model has an idea of how text is represented. It could understand text, and based on this understanding, we could make the model perform different tasks related to text data, right? So that is exactly idea we'll be doing. We'll be using so let's say we'll have a trained transformer. I'll just call that I'll say transformer, right? So after pre-training on all of this data, after training the model on this data, we'll be getting a model that is able to understand what actually text data looks like, because it is being trained on all of the information on the internet. We could actually use this model, right? We could actually have another layer, maybe based on the tasks. For example, if you are doing like text summarization, we could actually have a maybe a dense layer, or even any layer of your choice to predict different words. And we would actually create a layer on top of this transformer as the output layer, and we could fine tune this model on different data set. For example, we have data set for text summarization. So let's say we have a data set of different like many descriptions and a summarized version, and same we have like lots of data. So this is the new data. So this is the old data, the above data. So this is the old data, this is the new data, and this is like the description and the description and the shortened version or the summarized version. And we could actually use this data and train the model on this data. So what we could do is we could just pass all of these values, pass all of this to the model, such that the model understands how to solve this problem. And because the model already understands about text, that the model already has knowledge about text, because it's already trained on billions of text sentences, it could easily understand this data. As the model already understands text data better, it could easily solve this problem within like smaller number of epochs, within smaller number of training steps. And that is the idea of BERT. That is the idea of fine tuning. Essentially, we'll just keep the parameters. So we'll have a transformer, right? We'll be having like multi-head attention layers and dense layers and all that. So we'll be having like a specific set of weights. Consider all of these as weights. So like set of weights. After pre-training this model, we'll be updating these weights during training. So after training the model, we'll be having these weights. And in the case of fine tuning, when you're actually using the trained model, after training the model on billions of text sentences, in order to fine tune it for a specific task, let's say text summarization, we could actually get a text summarization data, like the description and the shortened version, and we could train this model on that data using these weights. Essentially, while we're training a model, we'll have initialization, and we could further update these parameters, right? We have already updated these parameters in the case of while pre-training. We could further update these parameters on that specific data set, on that new data set, such that the model can perform that specific task. And because it has already understood how text is or how text looks like, and different, it already has the ideas of the attention of words and all that, it could easily solve the problem. It could easily converge to the global minimum, or it could easily get to the best performance. So that is the idea of like fine tuning. As you can see here, we could actually build like many layers on top of that for our specific problem, based on that specific problem. So that is the idea of BERT. And another change that we could see in this paper is that, right, in a transformer, in a classic transformer, in a classic transformer model, so what we'll be having is we would have each sentence. So this is a sentence, right? And this is another sentence, let's say. So what we'll be doing is we'll be performing attention on this sentence, and also we'll be performing attention on this sentence separately, right? We'll be performing attention on this sentence separately and this sentence separately. And then after that, we would just perform attention on both of these sentences to make sure the model actually understand what the relation between these sentences in a classic transformer. But here, what we'll be doing is we'll be taking one sentence. So let's say we have two sentences, right? We'll be just adding both of these sentences into a single representation. So we'll be just concatenating this. So let's say we have two sentences. My name is Joel, and something like I play cricket, right? So what we'll be doing is, rather than dealing them as different sentences and performing attention on them separately, we will be just adding both of these sentences, right? I am Joel, I play cricket, and we will be performing attention on whole sentences, on the whole sentence, and behave like it was one. And we would actually add like a token here, saying like space token or something, indicating that there was a space in between and we have reached a new sentence. And by doing this, the model has not only learned the relation between the words of one sentence, but it has already learned the relation between sentences. It has learned the relation, let's say this word and this word, and also and while training, one more information is that almost all of the time we would put like successive sentences right next to each other. So let's say we have a huge description or a huge story, let's say. We would put the nearby sentences together, and like in the training data set, while we are doing like pre-training, the first training, we'll just put like sentences next to each other into like closer to each other while training, just to make sure the model understands how different sentences relate to each other and the attention of different sentences, and how one word of one sentence and how one word of one sentence can affect the meaning of other word in the next by sentence. So that is the idea of doing this self attention, through which we just add all of these values. We just concatenate them into a one specific representation. We would just concatenate them and perform self attention on this big representation. And that is actually very good use. And that hopefully enhances the performance, and hopefully you understand what is going on here. And I think that is BERT. And again, we'll be pre-training the model. We'll be pre-training the model on a large amount of text data to predict the next word, right? And after that, after pre-training the model can understand the relation between each word. It can understand like how sentences work, right? After that, we could actually use this model and fine tune it on our specific data set, whatever our data set is, and based on the needs. And hence, as the model is actually trained on, is already trained on a large amount of data, text data, the model will easily perform better on this new data set, as it already understands how sentences are actually built up. So that is, I think that is. But for this video, I think I'll stop it there. Maybe in the next video I'll provide some more details that might be useful. And yeah, I mean, thank you for watching. And if you have any confusion between that, I'll definitely recommend you to check out transformer video. And essentially, transformer is like basic, the backbone of all the language models. I have already told that, I believe. So that's it for this video. Thank you for watching, and I'll see you in the next one. So